Okay, hello. We are going to start with 9.2. Hope you guys had a good weekend and you are ready to get busy here. All right. We are at 9.2. Okay. So far, let's review. We solved quadratic equations in a couple different ways. First of all, if you had something like this, we used the square root method, where you took the square root of both sides, and the square root of 81 is 9, and remember you had to add that plus or minus. So there's your two answers, okay? Or if it was something like this, still, we could take the square root of both sides, and that dropped, and we got plus or minus the square root of 3, and then all we had to do was move the 4 over so that we got x equals 4 plus or minus the square root of 3. Okay, then once you added that third piece where it looked like this, because now it has that x, not just an x squared and a number, but an x. Now we did what was called completing the square. Remember, we moved the 2 over, so we got x squared plus 4x equals 2, and then we had to find out this number. And that was by taking half of that middle number and squaring it. So 2 squared, which is 4. So we add it here, and we add it there. Now, this will end up factoring. Multiples of 4 that add up to 4 are 2 and 2, and they get a positive 4. They're both positive. And the whole reason is, though, they're going to be the same, so you can rewrite it like this. Now you can take the square root of both sides, and then you're just like this problem up here. Move the 2 over, and you get x equals negative 2 plus or minus the square root of 6. Okay? That's what we've learned so far. Now we're going to learn something else, because what if I had 6x squared minus 5x minus 4 equals 0? Well, in order to complete the square, we have to get rid of the 6, which means we'd have to divide each piece by 6, which if I divided each piece by 6, look what happens. I get x squared minus 5/6x minus 4/6 equals 0. I'd have to move that over, and I'd have to take half of this. Ew. So instead, we're going to look at it and use a whole new method called the quadratic formula. And the quadratic formula, first of all, has to be in this form, which it is, where my A, my B, and my C give me a number. And the quadratic formula is a formula that looks like this, where A corresponds here and here, B corresponds here and here, and C corresponds here. The A, B, and the C, the numbers that are A, B, and C. Okay? Now, let me get a new whiteboard so we have some room here, and let's take care of this. All right. Again, our problem, well, first of all, and this is how I remember the quadratic formula. It's about a guy named Bob, and Bob's a real negative guy. That's negative Bob. Bob is invited to a party, and he says, I don't know, should I go or shouldn't I go? Well, he decides to go, and once inside the house, Bob square dances. He's having a good time. But he gets thirsty, so he stops dancing. He goes into the kitchen to get a drink of water, and he finds some people playing poker. And he says, oh, let me in. So he starts playing poker, and he ends up with this great hand, and he goes all in, and he ends up losing to a guy who had 4 aces. Now, the party was all over by 2 a.m., and he had a really good time. Ha, ha, ha. Okay, so let's look at our problem. 6x squared minus 5x minus 4 equals 0. So what is my A, what is my B, and what is my C? Well, my A is 6, because remember it's ax squared plus bx plus c equals 0. Remember that part of it. My B is -5, and my C is -4. So all I do is I replace wherever there is an A, a B, or a C. So the opposite of B is -5, plus or minus, oops, that's squared, B squared, minus 4 times A times C, all over 2 times A. All I did was plug in the numbers. Now, that gives me 5, because 2 negatives make a positive, plus or minus, -5 squared is 25. Now, -4 times 6 is -24. -24 times -4 is positive, I think it's 96. 96, all over 12. So x equals 5 plus or minus 25 and 96 is 121 over 12. And the square root of 121 is 11 over 12. Now, we don't leave it like this because this is actually, these are just numbers. So I have 5 plus 11 over 12, and I have 5 minus 11 over 12. So this gives me 16 over 12, which is 4/3. And this gives me -6 over 12, which is -1/2. And those are my 2 answers using the quadratic formula. All right, let's try another one. What if I had 4x squared equals 8x minus 1? Well, if you remember, it has to be ax squared plus bx plus c equals 0. Everything on one side, 0 on the other. So I'm going to move these 2 over. When I move them over, the 8x becomes negative and the 1 becomes positive. Now, my A is 4, my B is -8, and my C is 1. So the opposite of B, plus or minus, B squared minus 4 times A times C, all over 2 times A. That's what x equals. The opposite of B, plus or minus B squared, minus 4 times A times C, all over 2 times A. So the opposite of -8 is 8, plus or minus 64. Now, -4 times 4 is -16, and -16 times 1 is -16, all over 8. I'm going to come down here, which gives me 8 plus or minus, what's 64 minus 16? 48, all over 8. Now, square root of 48. The square root of 48 can be written as 16 times 3, which is 4 radical 3. So I have 8 plus or minus 4 radical 3 over 8. You don't get to forget all the things we've already done, and one of them is simplifying a radical. Now, I want you to look. All three outsides, can they be reduced? As long as all three of them can, we can do it. That could become a 2, that could become a 1, and that could become a 2. So my answer is 2 plus or minus 1 times the square root of 3, don't need the 1, over 2. And that's your answer. Okay? Now, what happens if we have something like this? 9x plus 3 times x minus 1 equals 8. Remember, in order to use the quadratic formula, you have to have everything on one side, 0 on the other. And right now it's not. And I can't move that 8 over because these things are being multiplied. So I have to FOIL out, move over the 8, and then start over. Okay? So 9x times x is 9x squared. 9x times negative 1 is negative 9x. 3 times x is 3x. And 3 times negative 1 is negative 3. Now I can combine like terms, so I have 9x squared minus 6x minus 3 equals 8. Move this over, I get 9x squared minus 6x minus 11 equals 0. All right, my A is 9, my B is negative 6, and my C is 11. So, x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. So the opposite of b squared, a, c, a. So I get 6 plus or minus 36. Now, negative 4 times 9 is negative 36, and then negative 36 times negative 11 gives us positive, I have no idea, let me get my calculator, 36 times 11 is 396. 396 all over 18, which is 6 plus or minus the square root of 432 all over 18. Now, the square root of 432 is not a perfect square, but we need to figure out if we can reduce this or not. Oh my goodness. All right, 432, let's divide it by 36. Aha! Oh, by 12. Okay, 432 divided by 64. No. 2. 30. 432. Okay. Guess what? 432 is 144 times 3, which means I can bring a 12 out, the square root of 144, with that left over 18. But look, do all three pieces have something we can reduce by 6? 1, 2, and 3. So my final answer is 1 plus or minus 2 times the square root of 3 over 3. And that's the quadratic formula. You plug in the numbers and you go from there. Plug in the numbers, go. Plug in the numbers, go. Okay? All right, that's 9.3. We're going to do 9.4 as well. 9.4 is the application of all of this. I'm sorry, that was 9.2. We're going to do 9.3. And 9.3 is an application of all of this. It's actually an application of everything that you have learned so far. Do we have an equal sign? Yes. So we are solving for x. When we had fractions before, how did we solve for x? This was back in 095. we multiplied by the common denominator to get rid of the fractions. Now here is where it gets a little tricky. What is the common denominator? Well, the common denominator is going to be 12x times x minus 1. This 12 has nothing to do with x minus 1, which has nothing to do with x. So you have to multiply all three together. Okay? So I am going to take each piece and multiply by the common denominator, which in this case is 12x times x plus, x minus, that's a minus, x minus 1 over 1 times 12x times x minus 1 times 12x times x minus 1. Now, by doing this, I'm going to get rid of denominators. I'm going to get rid of fractions because this x and this x cancel out. So I have 1 times 12 times x minus 1. So I have 12 times x minus 1 plus this and this cancel out. So I have 1 times 12x, which is just 12x, equals, here the 12s cancel out. I have 7 times x minus 1. So I have 7x times x minus 1. Now we multiply all this out. So I get 12x minus 12 plus 12x equals 7x squared minus 7x. I have an x squared. Everything on one side, 0 on the other. These two actually can combine. 24x minus 12 equals 7x squared minus 7x. Oops, not x squared. What am I saying? 12x and 12 is 24x. All right, so I'm going to move this over because I don't want a negative x squared. And I'm going to move this over. And let's see what we get. We get 0 equals 7x squared minus 31x plus 12. Well, we have the quadratic formula. We can solve this. A is 7, B is negative 31, and C is 12. So I have the opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. So B is negative 31, 7, 12, and 7. All right, positive 31 plus or minus 31 times 31 equals 961. Negative 4 times 7 is negative 28, and negative 28 times 12 is negative 336, all over 14. X equals 31 plus or minus 961 minus 336 is 625. All over 14. Now, 625 is a perfect square. It's 25. So I have 31 plus 25 over 14, and I have 31 minus 25 over 14. This one becomes 56 over 14, which is 56 divided by 14 should be 4. Yep, 4. And this one's going to be 6 over 14, which reduces to 3/7. All right. All of that from one problem. Let's try another one. What if I had 4 over x minus 1 plus 9 equals negative 7 over x. Well, this is a 1. What's the common denominator going to be? You got to have a 1x times x minus 1. Just multiply all three together. Now, you don't necessarily need that 1 because x or 1x is the same thing. So we're going to take each piece and multiply by the common denominator, which in this case is x times x minus 1. Okay, all right. Nope, I don't want the eraser. I want center. Okay, so this x minus 1 goes away. I'm left with 4 times x, which is 4x, plus nothing goes away here. So I have 9 times x minus 1 equals, here the x's go away, so I'm left with negative 7 times x minus 1. All right, so now we multiply out. 9x times x is 9x squared, and 9x times negative 1 is negative 9x. Negative 7 times x is negative 7x, and negative 7 times negative 1 is positive 7. Combine like terms, you have 9x squared minus 5x equals negative 7x plus 7. You have an x squared, so we're going to move everything over on one side, 0 on the other. You get 9x squared minus 12x minus 7 equals 0. Everything's on one side, 0's on the other, so now we can quadratic formula. A is 9, B is negative 12, C is negative 7. X is equal to, the opposite is B, plus or minus B squared minus 4 times A times C, all over 2 times A. All right, B is negative 12, A, C, A. So x equals 12, plus or minus 144. Negative 4 times negative 9 is negative 36, and negative 36 times negative 7 is positive 252 over 18. Okay, x equals 12 plus or minus 144 and 252 is 396. I don't think that's a perfect square. No. 396. What goes into 396? Aha. All right. Guess what? 396 is 36 times 11. So that gives me 12 plus or minus 6 times the square root of 11. That's multiplied. All over 18. Now remember, as long as it works for all three, and does it, we can reduce by 6. 2, 1, 3. So what's my final answer? X equals 2 plus or minus the square root of 11 over 3. Okay? All right, that's one of the things you'll do in 9.3. Another one is going to look like this. What if I had x equals 6x minus 8, the square root of it? Well, this is where we use that square root, or the raising powers property. This is a square root. If you square a square root, it gets rid of it. So in other words, I'm going to take this side, and I'm going to square it, and this side, and I'm going to square it. If I get x squared, when you square a square root, it drops, and you just have what's inside. Now, move this over. You get x squared minus 6x plus 8 equals 0. Let's see if it factors first. Are there multiples of 8 that add up to 6? 4 and 2. I don't have to use the quadratic formula. This one factors. Easy. 4 and 2. And you get a negative 6. They'd both be negative. Then you set each piece equal to 0. Move the 4 over. You get x equals 4. Move the 2 over. You get x equals 2. And there's your answer. Okay? So these ones, Not so bad, not so hard. Let's look at another one. What if I had 2x equals the square root hang on. Equals the square root of x plus 1. Okay. You can't square both sides until this is all by itself. So I need to move this over. So I get 2x minus 1 equals the square root of x. Now I can square both sides. This becomes 2x minus 1 times 2x minus 1, and that just becomes x because that and that cancel out. Well, you know we've got to multiply this out because it's not all equal to 0. We're going to multiply it out. So we get 4x squared minus 2x minus 2x plus 1 equals x. So I have 4x squared minus 4x plus 1 equals x. That's a 1x. So I'm going to move this 1 over, and I get 4x squared minus 5x plus 1 equals 0. Now I need to solve this. So it looks like I'm going to use the quadratic formula. X equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. So what do I get? Well, what's my b? Negative 5. What's my a? 4. And what's my c? 1. So I get 5 plus or minus 25. Negative 4 times 4 is negative 16 times 1 is negative 16 all over 8. So I get 5 plus or minus the square root of 25 minus 16, which is 9 over 8. So x is 5 plus or minus 3 over 8 because the square root of 9 is 3. So I have 5 plus 3 over 8 and 5 minus 3 over 8. Well, this becomes 8 over 8, which is 1. And this becomes 5/8. Okay? All right. Well, then there's 2 other things. And you know what? I honestly can't remember. I'm going to go through these just in case. I think I did an upstream and downstream. You know what? I'm not sure. So I'm going to stop here, and then if I did do some word problems in this section for you, I'll come back and I'll record that as well, okay? But for now, we're just going to leave it at this. That's 9.2 and 9.3, the computation part of it, okay? All right. Have a good day.